Question 18, quite straightforward. What is a superconductor? Something you must recall. A superconductor is where the electrical resistance is equal to zero. And this happens when the temperature of a metal falls below the critical temperature. And when the temperature falls below this temperature, and that's specific to that material, metal, then the resistance, the electrical resistance of that metal, drops to zero at the critical temperature and remains zero below the critical temperature as well. And that's what we call a superconductor, an electrical resistance of zero in a metal. Part two, with the aid of a sketch, explain the term critical temperature. And the best way to do this is looking at the resistance versus the temperature. And we know that for metals, the greater the temperature, the higher the resistance. And if you go backwards, that means that the lower the temperature and the lower the resistance, and up until you get to a point where the resistance just drops to zero. So here we will get a rapid decrease in resistance, and this happens at the critical temperature. And below the critical temperature, the resistance of that metal or that wire remains at zero. Okay, so as the temperature decreases, the resistance of the metal decreases. So I'm explaining this section here up until the critical temperature, which is this Tc, where there is a rapid decrease uh, in resistance to a value of zero. Okay, the material is a superconductor below the critical temperature. So below the critical temperature, the material has zero resistance and is known as a superconductor. So explain why superconductors are very useful for applications which require very large electrical currents. Name two such applications. So first of all, anything that has zero resistance is going to have very little power loss due to collisions of electrons. So when you have a zero resistance, those collisions per second have diminished, and therefore you do not have any power loss. So no resistance means no energy or heat or power loss. That's the first mark. And superconductors are used in so many different applications: electrical cables, generators, transformers, motors, very powerful electromagnets. Often they're in particle accelerators. MRI scanners will have superconductors, monorail trains, fusion reactors, etc., etc. So there are many scenarios where we will like the wires to not produce heat, and especially with large currents in power cables and electromagnets especially. So these are some applications where superconductors are very useful.